right, so this is the Monday 13th, third lesson on Zoom. So hopefully this is working out for you a little bit. Hopefully you're able to go to the YouTube. Use the chat feature, please, to ask questions, because I don't know what you're not understanding or you need me to repeat unless you're asking questions. So if you're curious where that is in Zoom, you just kind of move your mouse over probably where my face is at the moment. And then at the bottom there should be a little chat button. You can click that, and then a chat box will pop up on the right side, and you can enter in all your questions there. And if you're watching this on YouTube, email me a timestamp, and I can kind of elaborate a little bit. So we're going to hopefully get through, we will get through half of the stuff today. Well, I guess 1/4 of the stuff today. Then you'll be responsible for like 1/4 of it for tomorrow, just getting through it. And then again, the second half, we'll move on from there. But today, we're just talking about some stuff that we talked about right before we got out with geometric sequences, but we're also talking about comparing and contrasting them to something that I didn't actually teach you the first time around. It was before I got there, so it was a while ago, and that was arithmetic sequences. So they're a little different, and we're going to kind of talk about piece by piece what makes them different, and we can start there. What makes them different? So we'll compare and contrast them and talk about what makes them different. Okay, so we got two. We said we have arithmetic and geometric. Okay, so we have two different kinds of sequences: arithmetic and geometric. A lot of math words. There's really no way to translate them simpler than those two words. Are kind of just what you have to know. Similar to like a quadratic or exponential, right? It's much math vocabulary, but the more you use it, the more comfortable you get with it. But arithmetic sequences have a key difference. These two have a very key difference. When you are dealing with arithmetic sequences, you're dealing with a common difference. Okay, now that's compared to or contrasted against a common ratio. Okay, so what's the difference? Well, with the common difference, you are actually, the other marker, this means you are adding or subtracting. Now I'll get to adding and subtracting what exactly? I'll get to that in a second. All right. And then the common ratio, you are multiplying. Not dividing. You're multiplying by a ratio. Okay. Adding or subtracting what? So these are both talking about sequences and series, and what that is a list of numbers. Okay, so if I have the numbers 1, 3, 5, 7, ... Okay, so I have 4 numbers, and let's just say I'm trying to figure out the 35th number or something like that, but I don't want to keep adding them, or I don't want to keep multiplying them by the common ratio. I don't want to keep adding or subtracting by the common difference. And I want to just kind of get there quickly. Well, we can build formulas that you know are called explicit formulas to help us get there immediately instead of recursive formulas that kind of have us keep adding and keep adding and keep adding. But as a refresher on the base knowledge, this is our sequence of numbers, our list of numbers, our series. This would be the first term. And that first term is normally noted as f of 1. Okay. This is like the second term, third term, fourth term, and so on. All right. When we say like first, second, third, and fourth term, we're talking about like, imagine that these numbers are in elementary school and they're in line to go to the lunchroom. Okay. Well, this is the line leader. It's the first term. The second term is the person second in line. Third term is the third person in line. Fourth term is the fourth term in line. Okay, so you can kind of look at them as a list or as a line of people, if that helps. And so when we're talking about like the 35th term, that means I want to know what number is 35th in line without having to count each person, okay, or each thing in line. So that's my first term, my second term, my third term, my fourth term, okay. But what I'm looking for is either a common difference or a common ratio, and if it has neither, then it's not a sequence, okay. So if it has, let's check that. How do we check that? Let's first check for common difference. And what you'll do is you'll take the second term, you subtract it from the first term, subtract the first term from that, sorry. Get that backwards there, and then that gives me 2. All right. Take the third term and subtract the second term. That gives me 2. Take the fourth term, subtract the third term. So what you're doing is you're taking the next one and subtracting the last one. The next one, subtracting the last one. Hello, that's kind of familiar to what we did with the first and second differences. We took the next one and subtracted the previous one, okay? And that gives us this 2. Now that 2 number, what that means is it's saying that to go from 1 to 3, we added 2. To go from 3 to 5, we added 2. To go from 5 to 7, we added 2 again. So that's looking at a common difference because we're adding, okay? Because we're adding. Now, if it was a different group of numbers, it might look a little different, okay? And then we'll get to that here in a second. So if you have any questions, please put it in the chat. If you don't, this will be back on YouTube, so you can pause and rewind. So let me show you a list of numbers that are not, that might follow a different pattern. All last week and all this week, you're looking for patterns and how to kind of dissect the pattern and break it apart into manageable parts. All right, so if I have like 2, 4, 8, 16, and other stuff. Okay. If I have this list of numbers, this line of people, okay, 2 is still my first term, 4 is my second term, 8 is my third, 16 is my fourth, and whatever else is after that, it's after that. All right. To find, again, well, let's check, see if there's a common difference. And to do that, again, you take 4 minus 2, the second term minus the first term. That gives me 2. Then you take 8 minus 4, which would give me 4. Okay, immediately I can stop because I can say it's not the same number every time. So it's not a common difference. The common difference has to be the same between every number. Even just looking at it, you can kind of tell that it's not growing by the same amount. It's not the same as 1, 3, 5 because it's 2, 4, 8. Went up by 2, went up by 4. All right. So we're not dealing with the common difference. We might be dealing with something a little different or other options. So let's check for a common ratio. To find a common ratio, refresh you on this, you take the second term, which is 4, or the next term, which is 4, and you divide it by the previous, which is 2. That gives me a common ratio of 2. Okay, and you keep doing that to see if it'll keep working. And if it does, then you have a common ratio. And if it doesn't, well, then you don't have either. Okay, so then take 8 and you divide that by 4. Oh wow, imagine that. It gives me 2. And then finally, you take 16. See if I can, I'll do it over here. 16 divided by 8, and that gives me 2. Okay, so all 3 times I found a ratio, which is just a fraction over, or a number over a number. You found a ratio, 4 over 2, simplified, 8 over 4, simplified, 16 over 8, simplified. I'll give you 2, and it was common in all of the pairs of numbers. Right, so you pair up the first and the second people in line, the second and third, third and the fourth. You kind of do that each time. Okay. So now that tells me this is a geometric sequence because I have a common ratio, not a common difference. That's basically the core of what we're going to be doing this week, is doing that and then writing explicit formulas. So we'll get there here in a second. Hopefully this was all a little bit of a refresher. I know it's been a week or been a few weeks since you've looked at this. But again, we're going to keep doing this all week. So let's keep moving. Okay, so don't be alarmed by the 26 problems on this thing. You're going to be spending all week doing it, and I'm going to be doing some of them, not most of them, but some of them. Okay, so what the first, I think 10, the first 10 I want you to do is look at that list of numbers and then figure out if it's arithmetic or geometric, same way we just did. So if you need a refresher on that, rewind the video, go back and watch that. And I'm going to keep working through it. Then it wants you to state the common difference in ratio, write a formula, and then find the given term. We'll, again, get there when we get there. Let's start with figuring out which category it falls under. So let's take our list of numbers. Again, this is going to be starting with number 1, -6, 12, -24. The fact they only give you 3 numbers is not a problem. You need at least 3 numbers to figure out if it's a sequence or if it's either or. Okay, can't just do it with 2. You need at least 3. All right, so you can either begin to pick up on the patterns here and when to recognize what. Some of you probably will be able to pick up on, oh yeah, absolutely, I see it immediately. But if you can't, it's a-okay, not a problem. I would always start with arithmetic and then always move to geometric, just because it's easier if you fall into a rhythm with that. So let's check for arithmetic. Arithmetic, question mark. Again, here, this is our first term. If it helps, I'll write it in blue above. First, second, and third term. Okay. So arithmetic, question mark. So let's see. So to do this, I need to take my second term and subtract my first term. So 12 minus, don't forget your parentheses, -6. That's 12 minus 12 plus 6, which is a difference of 18. Okay, so now let's check the next one, which is -24 minus 12, which would give me -36. Compare those two. Those are not the same. At least in my book, they're not the same. Sorry, my computer on the other screen where I had the problem pulled up, logged out. So those are not the same. So is it arithmetic? It is not arithmetic. And it's not arithmetic because these two numbers, these two differences are not common. They're not the same. That's what we're looking for. Okay. All right. Now let's check if it's geometric. Again, to do this, you take the second term, which is 12, and you divide it by the first term, which is -6, and that's going to give us -2. All right. Then you repeat the process. You take the third term, and then you divide it by the second term. So you take -24. Hopefully, okay, yeah. and you divide it by 12, which again is giving us -2. Okay, bingo. What we now have is a geometric sequence because the ratio between the first and second term and the second and the third term is the same. So we can kind of see that from here on out, if we kept going, we would keep multiplying by -2 to get the next and the next and the next terms in line. All right, so let's actually figure out what this wants us to do. So representation, that's our numbers, okay? And that's going to have, it's our list of numbers. Next column is arithmetic or geometric. So you would write geometric right there. And then you would actually list out the common difference ratio. In this case, was -2. So this is a geometric sequence with a common ratio of -2. So you can put, r equals -2 or common ratio -2. Either one right there. Okay. So from here, we can take the explicit formula. Let's talk about the explicit formula. So it's not, I'm going to erase all this. So we have two kinds of explicit formulas that we've actually talked about and learned. One for arithmetic, the other for, of course, geometry. We have two options here. And we've already learned that this option, this problem here is geometric. So let's write I'm going to write the general form. This would be good to have down on paper somewhere. I'll write it a little bigger. So you probably remember this. This formula where a sub n is equal to a sub 1 times the ratio raised to the n minus 1. Let me kind of break down each piece of that before I just math you to death. This is basically saying the nth term or whatever when it says nth term, it means whatever term you want to find. So it is be the 100th, could be the first, it could be the, sorry, not the first, the second, the 50th, it could be whatever term you want to find. That's what it means to be the nth term. N is just a placeholder for a number. It could be, again, 50 or 100. And this formula kind of, instead of having us add them each time or multiply them each time, we can go jump straight there. So don't be scared by this nth term vocabulary because that basically just means whatever term you want. We've already talked about this a sub 1. This is our first term. That is our common ratio. R for ratio. Sometimes as mathematicians throw you a bone, make things a little easier. And again, this n is important though, because this is also the term number that you want, okay? So if you want the 100th term, a sub 100, that same 100 needs to go there, okay? So you can't can't use two different numbers there. You have to use the same number there. Okay. So that's how the formula breaks down. I'm going to erase this bottom part and kind of leave that up there, and we're kind of going to work through the formula. Okay. So So for this, we need a couple things. We need to know, well, let's write down what we need. Okay, we need the first term. We need the ratio. That's it. Need the first term and the ratio. All we're doing is writing the formula. We're not actually looking for a term yet. So we're not looking for the 100th term quite yet. So you don't actually need any number in the end spot. All we need is that first term, which is a sub 1, and the ratio. Both of which, one of which we found, the other which was actually given to us in the problem. So the first term is up here, and that is -6. And we actually found that ratio. I erased it. It was right here. That common ratio was -2. Okay. So now that we have this, we can actually fill in the blanks for our formula. So for the explicit formula, it's going to be A. So man, you usually leave that. Oh, the glare is probably getting this, huh? There we go. A sub n. And then you actually fill in the blank on the first term. So -6 multiplied by -2, close parentheses to the n minus 1. That's the whole explicit formula. That's all you got to do. We found the parts to it. We found the whole. Okay. Fill in the blank. First term, common ratio. Any questions on that? It's okay if you don't have any necessarily, but if you do, please, please, please let me know. We're not quite done with the problem. There's one more thing, but this one's actually pretty straightforward. So I'll do this in a different color over here. So to find the last thing this problem wants us to find is a sub 10. Sub 10. Okay, the last thing it wants us to find is a sub 10. So let's write out the formula and then plug in 10 wherever n goes, okay? So we have a -6. Use the formula we just built. And then notice there's an n up here. So, or I guess I can point up here too. That's where our 10 is going to go. Remember, it's 10 minus 1. So let's refill it all back out. So a10 is -6, -2. 10 minus 1 is going to be 9. So again, we're looking for that that 10th person in line. And then to do that quickly, by just kind of glancing down the line and looking at the 10th without having to check the roll and go down the line, count each one, we use our explicit formulas to do that quickly. So I have I'm using my Desmos calculator, so you can as well. Okay, and that 10th person in line is going to be 3072. That's the number. That is the 10th person in line for this list of numbers, this line of numbers. Okay. I know it was a lot, but I'm going to go through an example, a couple more examples here. Okay. Let me know if you have any questions. I'll be happy to ask them. Okay, so I'm gonna, I'll do number 3 actually. So -10, -8, -6, -4. Is that right? Yep. So let's just look at that and see if we can find a pattern already. -10, -8, -6, -4. Kind of seems we're counting by twos, right? So if we're counting by the same number every time, that tells us we have a common difference. Let's check that though to make sure. So is it arithmetic? Question mark. So we take -8, subtract -10. That gives us -8 plus 10. That gives me 2. -6, subtract -8. That is -6 plus 8, 2. -4, subtract -6. -4 plus 6, 2. Look at that. I have a common difference there of 2. Okay, so we just found the first and second part of the problem here. It is arithmetic. Yes. It is arithmetic. And my common difference is 2. Any questions there? I know that was kind of quick. But again, what you want to do is take the second term or the next term and subtract the previous term. So take the second term, subtract the first term. Take the third term, subtract the second term. Fourth term, third term, and so on and so forth. Okay. And you can only do it for the ones that you have in the list. And all of those numbers are the same, so that checks out. All right, so I have a common difference. My common difference is 2. Now I get to write an explicit formula. So my explicit formula here is actually going to look a little different because it has to. So I'm going to write this one here. Actually, let me do this. Do this a little differently. The explicit formula here is actually a sub n, so that's not new. Don't let that freak you out. Nothing crazy going on here. This is actually not an R. You know, my handwriting might tell you otherwise, but it's supposed to be an N. Okay. So again, this is the nth term. Whatever term you want it to be. I know that's glared. The nth term, whatever term you want it to be. This is again our first term. This case is -10 up here. The line leader, the one that comes in front. Okay. This, instead of our common ratio, since we're dealing with a completely different kind of sequence, you have arithmetic sequences which have common differences. D, again, is going to stand for difference instead of R for ratio. This is our common difference. And again, this is term number. Okay? So, similar, not exactly the same. Similar because we start using the first term, we're still using the term number. Just to get the order and how it's arranged is a little bit different. So it's important when you're solving all these to have both out in front of you so you don't get them all mixed up and labeled above. This one's geometric, this one's arithmetic. Kind of go from there. Okay, so I'm going to erase this stuff up here. That way, I have some room to write. So again, we're going to figure out what we need and then plug it into the formula. What we need. So we need the first term and the difference. So we know our first term is negative 10. You know my common difference earlier is written right there. It's 2. So let's fill in the blanks and kind of fill in the formula. So if we have a n, the first term is negative 10 plus 2 times n minus 1. And it's supposed to be an n. Okay. One of these days it'll stay. All right. So that is our formula. I erased that. That's the explicit formula filled in. That's what you want in that column. You want the general formula down here filled in with the specifics that come earlier in the problem. The first term and the difference, the first term and the ratio. Okay, so this one wants us to find the 56th term. Don't be too scared though, because all you do is you plug in 56 for n. You get out a number, hopefully. So I'm going to use my calculator here for a second. Negative 10. You just plug it in, just like you have it. And you get 100. So 100 is that term we want on the end over there. So again, let's go left to right, looking at the columns. Arithmetic or geometric. This one is arithmetic. Next, common difference or ratio. The common difference was 2. Explicit formula was this business right here. A sub n equals negative 10 plus 2 times n minus 1. I got that from this general formula and then plugging in what I know, what I found, which was the first term and the difference. To find that last column, the given term, you just plug in the number they're looking for, in this case it was 56, in to the problem for the letter n. That's our variable for the given term. Okay, so I'm going to do another one of these. Let me actually skip down to, the next page. Let's go ahead and scroll down to the next page. And what we'll do here, for each sequence, state whether it is arithmetic, geometric, or neither. So this worksheet actually kind of works backwards a little bit because we already covered how to do that, but then we had more steps added on. So let's look at like this one. Let's check 1, 3, 6. This is number 1. 10, 15. Okay. So this one, 3 minus 1. So let's just check for arithmetic. 3 minus 1 is 2. 6 minus 3 is 3. Okay. Not arithmetic. Then let's check. So 3 divided by 1 is 3. 6 divided by 3 is 2. So it's not geometric. So it's neither. That's the process you want to do for all of those, the first 6 there. You just want to check, see if it's arithmetic or geometric. So on Wednesday, I'm actually going to pick up on the 3rd page. So find the first 4 terms sequence and then find the 10th term. So don't get to that yet. Try the first 2 pages over these next 2 days. It looks like a lot. Get to what you can. I'm going to do a couple more examples here. So, for instance, number 2. Number 2 has us doing 40, 43, 46, 49. That all it gives us? 52. Okay, so let's check if it's arithmetic. That means common difference. So let's take 43, subtract 40, that gives me 3. Let's take 46, subtract 43, that gives me 3. 49 minus 46, that gives me 3. And 52 minus 49, that gives me 3. I got 3 when I subtracted all of them from the next one, or the previous one. Okay. That tells me I have a common difference. So check mark. Yes, it's arithmetic. So right underneath that, you would just type arithmetic. All right, and that's kind of the process for those 6. You just want to figure out, do I have a common difference or a common ratio, and go from there. So I'm going to skip to number 7. Yeah, let's do 7. So again, good thing this is on YouTube. You can pause and go back. So 7. Okay, so we have 1, -3, 9, -27, 81. Okay, so it's not going to be arithmetic because look at the difference there. That's a difference of 4. That's a difference of like 12. That's a difference of 36. So it's not going to be arithmetic. So let's just skip to geometric. So let's check. Let's see here. So I need to find my common ratio. And to do that, I take -3, or my second term, and divide my first term. That gives me -3. I then take my next term, which is 9, divide the previous term, which is -3. Let's do it one more time to double check. -27 divided by the previous term, which is 9. You gotta take each pair there. Okay, and that's also going to give me -3. So my common ratio here is -3. Okay, and it wants us to find the next 3 terms in sequence. Okay, so let me erase this one real quick. So I have 1, -3, 9, -27, 81. I need to find blank, blank, and blank. Okay, now if I went from 1 to -3, I multiply by -3. If I went from 3 to -9, I multiply by -3. That multiply by -3 is the same exact pattern. So to get this next number, I would multiply by -3 and follow that pattern. Whatever that number is, I can go ahead and fill this in because I know I'm multiplying by -3. Okay, so let's go from 81, let's get the next one and go from there. So if I have 81, I'm going to multiply it by -3. What is that, 240? 81. Yeah, 243. So that gives me -243. So that's one of them. And then I take -243 and I multiply that by -3. So I got I'll fill it in blue, -243 there. And I multiply that by -3. That's going to give me 729. So 729. Okay, and I'm going to multiply that by -3. This is a big number. So can you see this down here? Yes, you can. 729 multiplied by -3 is going to be -2187. So -2187. Okay, those are my next 3 terms in the sequence. That's what 7 through 12 wants you to do. Okay, and it's a lot, I know. We're almost like 45 minutes into the call already. So I'm not gonna take up any more of your time this morning, but we will be live tomorrow with questions to answer any questions. We both, someone and I have whiteboards, so we can work out any problems you want us to work out. We're gonna try to pace you through this. There's a lot of problems in here, but just do a couple at a time, take a break, come back to a couple more, rewind the video, break it into chunks, do a couple problems today, try to get maybe half of that first page done today, and if you can sprinkle in a couple from the second page and come back tomorrow, do it again. Okay. Maybe go ahead and jump through 1 through 6 in the second page, because those are quick problems. Just real quick, is it arithmetic or geometric? Or neither. Okay, so real quick, you can get through those. The first 10 are a little more involved, I guess. And if you're having problems typing the formula onto Cami, don't stress. Give it your best bet, and I can pretty much interpret what I'm trying to see or what you're trying to type. Okay, but as long as I see you're doing your best and not just scribbling some stuff down, that's okay. All right. So I'm gonna go ahead and stop it here and post this to YouTube. And again, I'm by my computer for emails. I'm by my computer for remind texts, anything. Let me know if you need anything, and I will be happy to get it to you. Thanks for coming today, and I'll see you guys on